Cool. We are recording. So tonight is November 29th, and it's kind of closing in on the end of the semester, and that's kind of scary and exciting at the same time. Uh, Today is Intro to Python. Next week is diving a bit deeper with Python, and then the following week is the final, which is kind of crazy to say. So some context for you all. Next week's lab will be similar in length to this week, if not a pinch longer, but it's kind of following the same uh, overall kind of lessons of getting started with Python for GIS people, because at the end of the day, that's what we're all here for. Learning Python for the sake of Python is fine, but having a slightly more geospatial kind of context is going to provide the most value for you all. So um, after next week, it's really kind of summing things up and kind of testing your knowledge of what you've learned this semester. I think that if you're following all the labs, completing them, and it generally makes sense, you should have no concerns for the final. I will be sharing a study guide next week about what to expect. Full disclosure, I've not created that. So that should be coming soon, mainly but I would not worry too much about the final. It's really kind of similar to everything else we've done this semester, kind of maybe an overview of what we've done, maybe a little bit of new, what to expect next semester in applied remote sensing. So I just want to hopefully relieve any stress that might have been brewing over the holidays, that hopefully we can finish out the semester strong. And yeah, so far y'all are doing really great with assignments. So just keep doing what you're doing. That being said, trying to think of any other housekeeping items. Yeah, I guess the last day is December 13th, which is kind of wild to think that's in 2 weeks. But I will do my best to grade everything in a pretty timely fashion by like the 15th, hopefully. But I'll keep you posted if anything comes up. But this weekend, I'm going to kind of do another grading session of everything that's been submitted up until probably Saturday of this week. And then you'll have a more up-to-date view on your score. And then also a reminder that there's the extra credit opportunities. I'd encourage you to participate them. And yeah, that's extra ways to earn points to boost your grade and also to learn, because at the end of the day, getting points and grades is kind of not really why we're all here. I mean, it is on some very real levels, but also we're trying to learn and build our skills. So I hope the points incentivize you, but you stay for the knowledge and get some curiosity of your own, which I think you will. So with that being said, are there any questions? I'm happy to answer them either live or DM me, email me. I realized I did not check my email over the holidays for this class, so my bad. I think I had one email that I need to get back to, and sorry about that. But if there's any kind of questions, feel free to either unmute, post it in the chat. So, really. Okay, cool. Seems like there's no questions, so I'm just going to proceed with jumping into lecture slides. Another short one this week because I think we're all mostly here to get some experience with coding and not to watch me talk over Google Slides. But if you want to follow along, I encourage you to go to the website Google Slides section, which I will share. So, basics of Python programming. I'm gonna share screen. And get going. Cool. And of course, you all disappear because Zoom has Okay, so my Discord is superior. And right, so 6 of Python programming, and let me pull up the chat. I feel good. It building. Okay, basics of programming. So today's objective is really familiarize you with some of the fundamental concepts and practical function of Python. It's this common language in the sense that you've probably heard about it if you're at all like online and kind of curious about data things. It's kind of thrown around as this topic that I feel like has grown larger than the language itself. So hopefully we can just bring that back to earth today and realize that it's not this magical like spell casting that we're doing, and it's very attainable and doable for everyone. And then I guess that's kind of in line with building self-confidence as new developers. But to kind of tie it all in with what we've done so far, we're gonna kind of use GitHub and connect previous week's lessons. I want to say maybe week 3. It's a blur at this point, but we're going to use GitHub and kind of store artifacts of our Python. And so here's a nice little GIF, meme, GIF. Do not run Python on your computer. Almost. There will not be any code exploding out of your computer tonight, but no promises. So Python, what is it? Copy definitions and links. Context. Python is a high-level programming language, syntax easily readable, extremely user and so the GitHub blog. Voice cutting off. Thank you for letting me know. Is this better? Raising the volume a bit. It can be used in a variety of applications, and its uncomplicated nature makes it an excellent language for automating tasks, building websites or software, and analyzing data. So for geospatial professionals, I'd say the automating tasks are zero, like do that. Now it's is that still happening? The because like my hotspot if necessary. Let me know. Sure. Technology. Yeah, let me turn off my call. I'm still here. Let me know. No, figure that out. Update the second one later on. I want to say that was for like a Microsoft resource. So both of those definitions kind of reference some content that not all be familiar with as so just any better or is it still okay, give me a second. Let's do some hotspot action. Sorry, my dude. Yeah. Spectrum does me dirty sometimes. And then I didn't have power like all day Monday, which was a huge bummer. Sorry, Fernando. Yeah, this is the stuff of nightmares. Builds character. Give me a second. Hopefully so I might cut out for a second, but I'm just joining the hotspot, so I'll be right back. any better or just as poor? Please let me know. Yes, I can say less. Yeah. Any better? Or should we start yelling at AT&T? It could also be my hardware. So I'm gonna just keep ranting. Okay, seems good right now, talking consistently, no cutouts. Okay, cool. Let's go on. I will if it sucks again. But AT&T should be MVP of the night because Spectrum sucks. But I was saying earlier, there's some terms that were mentioned in the previous slides that are a little more computer sciencey engineering based that might not be as familiar to you all as GIS professionals, and that's totally okay. But I just wanted to get on the same page. So Python was referred to as a high-level programming language. And so this is a language easier to use in the sense of natural language elements like human languages. I really want to do like the Talladega Nights, just like straight up NASCAR. It's got my beats ladder sponsors. All right. I changed my audio source. How's that? Can you hear me now? Hopefully that's better. Okay. Um, technology. Okay. Um, so high-level programming language has more kind of human understandable components that are almost like grammar that you would understand as some kind of weirdly abrupt human readable language. When you start looking at Python, there's some aspects of it that are going to be very similar to how you might just think of things as a person. There's other languages that are totally removed from that reality and are literally thinking about things as like zeros and ones. And so that's a supreme difference between Python and other languages like assembly or even things like the C languages. They're called lower level languages. And so you have to think about things like managing the memory of where bytes are stored and how data is kind of passed on the computer's hardware. Whereas Python, you don't have to worry about any of that. It kind of just magically works. And it's because it's a higher level language built on top of other languages. Python's actually written using C and Java, depending on the flavor you prefer. But it's such that you don't have to really worry about a lot of the computer internals that you do need to worry about with other languages. And so as a more novice developer, that's super nice. And then secondly, an interpreter or an interpreted language is a computer program that directly executes instructions without requiring them to compile into a machine language. And so when you're writing Python code, you can kind of just run it and it'll magically do things. You don't have to wait for this step called compilation that's common in other programming languages that has its own benefits, but for the sake of learning is kind of unnecessary. And so with these interpreted languages like Python, you're able to iterate much quicker, practice, make mistakes, and fix them. And you don't have to wait for the computer to magically translate your code into this other computer code that you can't necessarily read before it can even run. There's definitely benefits to that, i.e. performance. And so certain software applications need to be as fast as lightning, to use a metaphor. But
that's when you want to use a compiled language because it'll be way faster. Python is not the fastest, and I think I mentioned that a little later. So thankfully, this slide does not have snakes, another cute animal, but the main drawback of Python, because it's so convenient, um, some people think that it's the perfect tool for everything. And theoretically, you could probably do everything with Python, but it's kind of like the metaphor of cutting grass using a razor blade versus a lawnmower. Sometimes it makes sense to use a lawnmower. And Python is, in certain contexts, not a lawnmower, but namely the speed thing. And so this is kind of a joke where the fastest Python app is still pretty slow. And for the cases of analysis, that's not as important. This meme is more accurate for maybe a social media app like X or TikTok. That is probably not written in Python because it would not be fast enough to handle just like all the users simultaneously doing stuff. Whereas if you're running an analysis on geospatial data, Python's perfect. So I'd say the one takeaway from this slide is realize Python's great, but it's not always the right tool for every job. And as you kind of dive deeper into your development careers, whether that's going full off the rails, you're coding every day, or more just higher level understanding and appreciating what engineers do, I think that you'll realize that there's certain better tools for certain jobs. And to kind of close out this lecture, which I like to keep short and sweet generally, I've just provided some links to uh, common or like big GIS projects or companies and code that is Python that they have. And so before we jump into the lecture, I'm gonna kind of minimize this and then we can, this is the last one. Okay, cool. So let's visit some of these links. And I'll share these in chat so that you can inspect at your leisure, but they're also in the PowerPoint. This is Esri. They have 6,000 plus public Python files on GitHub. So that's a lot. They're doing it for a variety of things. You can kind of get an intuition on what the purpose is based on the repo title, but that's not always the case. This one is something to do with raster deep learning, which is kind of cool. Maybe we'll do that next semester, who knows? Some of this is related to like lower level data API declarations like protobufs, which you don't really need to worry about, but you can see that these are examples of Python and how they're used in the industry, which is pretty sweet. You can view all this and kind of learn how professionals are coding. As an analyst, you might not be writing the same style of Python, but learning kind of some industry best practices and style from pros is valuable, whether you're an engineer or an analyst or some kind of hybrid person. And so I'd say check out some of these repos. You can see that a lot of them are just kind of like samples that give you kind of a guided walkthrough of how to do things. Some are probably better documented than others, but you can see there's links that perhaps give some explanation. So I'd encourage you to check this out. Esri's they're a huge GIS company, and I worked there for a bit, and I use Python all the time. It's super useful as a product engineer, software developer, you name it. So a slightly smaller, but equally impactful GIS company is Planet Labs. They do high resolution spatial data from microsatellites. You can see they have over 1,000 Python scripts on their public GitHub repository. And so you can see a lot of these are, which is kind of cool, examples that you can check out. And these are curated by these companies. So it's a great way to learn from the people that actually built the product. And you don't have to like know anyone, which is kind of cool. It's just all available. And look at all these different examples of analysis, forest monitoring, NDVI, which is a type of remote sensing spectral index that I believe you've learned about. And if not, we'll learn about it next semester. But they give code examples on how to calculate some of this stuff and do analyses, which is super cool. And this is all free and open source. So this is some of the stuff you can do with Python. And this is some of the stuff that industry kind of leaders are doing with Python. So I didn't want to just represent industry, so I did a little digging and found some kind of more government-based examples of Python usage. So this is the city of Los Angeles. There's over 150 Python scripts. You can see some of them are related to, I guess, water networks, COVID-19, the Waze app, but they're using Python. So I'd encourage you to check out the ways that your local governments are using these technologies. And then finally, I think this is the LA Metro, over 200 plus Python files pushing to GitHub. So they're automating some of their workflows, logging. So that's pretty cool. Pandas, this is something we'll see next week and next semester. But I'd encourage you to just browse through this, see what makes sense. I mean, not right now, but after tonight and next week, check out these resources and see what is starting to kind of click in your head, what still doesn't make sense, and bring it up with class and let's kind of discuss. Happy to go over, maybe there's a particular script that looks interesting to you that you'd like more insight into. Happy to spend some time doing that next week. So just let me know. But that's it for slides tonight. Let me take a quick sip of water, open the floor for questions, and then we can toggle to the lecture or the lab assignment, excuse me. I'm out of practice of talking. It's actually a surprising physical feat speaking near nonstop for 2-3 hours. Ooh. My day job, I'm just sitting there silent all day, so it's a change of pace. Okay, doesn't seem like there's any questions, so let's just dive into the lab. I will share a link to the lab in chat, and let me know if I'm just totally disregarding people. Like I don't hear that there's anyone unmuting, and I don't see anything in chat. So let me know if there's audio issues on my end that I'm not hearing, but I think I'm good to go. But here is today's lab assignment. It's worth 20 points, and it's kind of an introduction into the wild world of Python for geospatial people. So at a high level, we're going to create a GitHub repository, and then we're going to run through each of these lessons and upload the completed lesson to that GitHub repository. And then we're going to submit a link to that repository as the deliverable in Canvas. So I've included those instructions here. I've updated Canvas to accept a URL and updated the points to reflect this. And so today, for the remainder of class, we're going to walk through these 4 lessons. So let's start out by creating a GitHub repository. I'm at my GitHub page. Handsome double. Let's toggle to the repository section and let's create a new repository called Python Part 1. And so I encourage you to follow along in real time if you like, or if not, just can watch me and do this later. So it's really whatever works better for you. So we're not going to use a template, but we are going to call it, actually, let me move these instructions over here so that I can see them and I don't have to constantly toggle. Okay, perfect. I have goldfish memory at the end of the day, so I really do need to see those instructions. I will not remember. Started at 6:30 a.m. Pacific today. That's the joys of working in an international company. When your boss is based in England. Okay. So I would create a public repository called Python Part 1, select add or readme. Don't have to worry about git ignore or license, but it should be good, and name it Python Part 1. Cool. Now we have an empty repository. So next, let's go to the first lesson for today. And before we dive into that lesson, I want to do a quick kind of shout out to the creators of this resource. I believe it's from the University of Helsinki, but I could be wrong. But it's like this amazing, University of Helsinki. So they have this whole open source learning resource. This is the first course in that kind of progressive learning experience. And the second course is automating GIS. And so in this course, the GeoPython, it's really like an introduction to Python for GIS people. And then the automating GIS resource is kind of once you've learned the basics of Python, here's a lot of the cool stuff you can do in the world of GIS. And so I'd encourage you to, I mean, we're going to work through a lot of this tonight and next week, but check out Automating GIS. It's an amazing resource, and I'll share links to that in Discord and in Canvas probably next week or during the final. But there's amazing educational content online for a lot of stuff, not just limited to Python and GIS. So I encourage you to do some browsing. I've been aware of this, not the GeoPython resource, but the Automating GIS resource from Helsinki for a few years now, and it's been super helpful in learning how to use some very niche kind of geospatial Python tools. So I'm really excited to share this with you all. I have no affiliation with Helsinki, but I just think it's a really great learning resource, and encourage you all to maybe try to find your own version of this for whatever niche interest you have outside of GIS, because there's a lot of cool free educational content out there. But yeah, let's go back to the first lesson. So the taste of Python. This class or this lesson kind of gives you the option to run Python in your browser, which is really nice. So we don't have to install anything locally. We're going to do that using the Binder option. So Binder is this kind of tool that lets you have code running in your browser of different languages. Today we're using like a Python environment. University students at Helsinki have a different way to enter and do their assignments, so we're not doing that. So I encourage you to click the Launch Binder option. If you do want to run this a different way, you're also able to download the file here at the top, either the kind of Python notebook or a PDF version of this lesson. So let's launch this with Binder. And this might take a minute or two to kind of launch, but it's creating a computing environment for us to run this code. And it's pre-populating with a bunch of Python and some empty cells too for us to run. And it'll just take a moment. You can see it's kind of loading. Hopefully the system does not get overrun with all of us connected today, but I think we should be fine. So you can see this is pretty similar to what we were looking at before, except the interface is slightly different. Now we're inside of this kind of white screen. This is called a Jupyter notebook environment. You might hear that term thrown around by Esri, other companies, even some of the resources I've shared. It's a way to kind of have text and code in a single document, and it's super useful for sharing kind of exploratory analyses or demonstrating some kind of technique to your colleagues or students. And so we're going to be using Jupyter Notebooks tonight, and we're able to run this from our browser, but like I alluded to previously, where we can run this locally or in a variety of different environments. And as you're working through this today, make sure that you save your changes. You can do that here from the file dropdown or using some of these shortcut icons. And then once you finish this lab, make sure that you click download and save this locally. There's ways to kind of connect it with GitHub, but I don't think we're gonna worry about that today because sometimes authentication can be annoying. So we'll just have a manual download step there instead. So let's jump in. Hopefully we're all on the same page here with this binder. Let me know in chat or by unmuting yourself if you're stuck or it's not working, but I'm gonna proceed in the meantime in lieu of any feedback that would suggest you're blocked. Yeah, today we're going to learn some of the basic operations that you can do with Python. And this is inspired by the Software Carpentry Organization's Programming in Python lessons. That's another great open source resource that's free for learning how to do a variety of computing tasks, whether it's kind of data analysis, data munging, using tools like Python or R. So I'd encourage you to check out Software Carpentry, Data Carpentry, Library Carpentry. Like I mentioned previously, this is a Jupyter Notebook, and it's going to introduce you to the basic concepts of programming in Python. This document has cells, which can either be text, which is markdown formatted, something that we've encountered previously in GitHub. You can also have raw text, which kind of doesn't get rendered nicely. It's just ugly, but it works for certain use cases, or Python code. There's Jupyter Notebooks environments for other programming languages, but I'd say the vast majority are in Python, and those will be the ones you'll encounter this semester and next semester. When you're running through these examples and kind of writing your own code, you can run the code using these icons at the top or using some of the keyboard shortcuts. The one that is, I'd say, used most commonly is Shift-Enter. That's how you run command from the keyboard. You just do Shift-Enter and it executes the current cell and then goes to the next one. For the cases where it's just markdown, nothing happens. It just kind of renders it. But you can see here, this is the raw markdown. If I do Shift-Enter, now it goes back to the rendered version because it executed the markdown kind of rendering process. Enough about markdown. So we don't have to launch JupyterLab because we're already in JupyterLab here. But if you were doing this locally on your own computer, you'd have to install something called Jupyter, kind of turn it on, enter it, do that. But Binder is this really nice alternative for learning. So be thankful you don't have to worry about Jupyter today. So I know math isn't super fun, but it's kind of one of the most useful things that we can have computers do for us is a lot of math because we make mistakes as humans. And so math and mathematical analysis type operations are some of the bread and butter of Python and many programming languages. So let's start by doing some simple arithmetic. So I'd encourage you to type 1 + 1 and then do Shift-Enter and see if you also get this result. And let me know if maybe you don't. I think you will though. And similarly, you can do multiplication. So addition is plus sign, subtraction minus sign, multiplication is the asterisk, and then division is a /. You can edit and rerun code simply by editing the contents and rerunning it. And you see that the computer will automatically run the code for you, which is pretty nice. So this is some basic math. You can see how these are super trivial examples, but imagine you have data that you need to kind of adjust for some kind of atmospheric correction. That's math at the end of the day, or just, yeah, I'll end it there. Math is useful. So oftentimes it's annoying to just code out these operations over and over again. And so functions allow us to perform these operations more efficiently and seamlessly, but also kind of combining code logic to make more complex operations that you can perform. And so let's try out some of the built-in functions that are available with Python. So we can kind of simulate the use of like echo from our terminal days using print. Reminds me of echo. Oh, you can see my first typo of the night, but this is good. This is kind of a foreshadowing of what you'll encounter on your Python journey. Don't worry about the red font color. It's not angry. It's just trying to let you know what's wrong. And you can see how there's pointing on the kind of code line where it perceives the error. So I was just missing a closing parentheses. Now, if I run it again, there's no error to be seen. So that was just using print. Another example of built-in functions that's a little more mathematical is something like the sine calculation. So throw back to trigonometry, and you can see that I do not have sine installed, or it's not imported. So that's fine. Another one is square root. This one might also not be imported. And so this is something where you actually have to import libraries to invoke certain functions. And so you can see that the print works just by default, but this square root and the sine does not work. And so we actually need one more step. So we're going to import the math library, which has a lot of these built-in math functions for us. And there's a variety of these libraries that exist for generalized and specialized purposes. Math is one of the more generalized ones, but GeoPandas and Pandas are more specialized towards spatial data analysis and data analysis, respectively. And so now that we've imported math into our working environment, we can invoke the sine function without error, which is pretty cool. Similarly, we can do math square root of 9, and hopefully we get 3. Nice. So in summary, we were importing a module, which sometimes you'll see referred to as a library. Can be a group of modules. I think that terminology is not set in stone. So I'd say they can be used interchangeably, but the module is probably the smaller of the two with respect to at least code complexity. And then you can load these modules using import, which we did here on line 9, or it's not line 9. And then you can invoke kind of the sub-functions of a module by putting them after the module name. And so you're also able to import a function from a module, so you can just use that directly. And so I'll show you an example of that right now. First, let's show you what MathPy looks like. So there's built-in constants. So let's use that built-in constant and make it so that we don't have to type math.py. So this is called import aliasing. So import math.py as pi. And we got an error, which is fine. Oh yeah, because math.py is already imported. So never mind. Ignore this. We'll come back to this import aliasing later on. So sorry if that was slightly confusing. Ignore that last slight tangent about pi. So to test your knowledge on Python so far, let's try to calculate the sine of pi. I'm gonna give you all a second to try that out, and then I'm gonna answer it in real time. So I'd say if you haven't already answered it, I'll give you another 20 seconds, and then I will continue. All right. Wasn't really counting, but it feels right. So let's do, we want to calculate the sine of pi. So if we just want to output pi, we do this, right? Yeah. And then if we want to get the sine of something, we have to do like math.sine something. So here we could actually put pi in parentheses and then do something like that. Nice. So there you go. We calculated the sine of pi. Sine of pi is 0. Is our math correct? 1 times e to the negative 16, that's effectively 0. So yeah, might seem like it's wrong, but that's essentially 0. Cool. So we checked our understanding. We used a function and we put in a default value into that function. This is some syntax and terminology that you'll probably encounter many, many times in your journeys with Python. So just wanted to kind of give you that exposure early on. You can also combine functions, which is another common thing. So let's try that now. Let's print the value of the square root of 4. So if we take math.square root, this is where we get the value of 2. But the Jupyter Notebook is a special case where even if you just run this without the print command, it'll print it out. If you're running this Python code in other environments, nothing would actually be printed. And so running the print command explicitly triggers Python to print out that 2. So it doesn't seem like there's a big difference, but you'll encounter this more and more as you use alternative development environments besides Jupyter. Cool. So we're kind of slowly building more complicated function logic, kind of nesting these functions. We can also combine values inside of a print function to kind of concatenate information to create more complex kind of sentences. So let's take the print function and then let's use it to print out this sentence, the square root of 4 is 2.0. So from above, we can see that the way to get the square root of 4 is to run this. So if we want to print out the square root of 4, just the actual value, we'd run this. But if we want to print out like a sentence, think what happens here. Nice. So we can write the square root of 4 is 2.0. Nice. And you can see there's an extra space because Python automatically inserts a space when you kind of do this comma separated print syntax. And so we don't actually need the trailing space. The square root of 4 is 2.0. Nice. I guess the positive square root, the negative square root would be -2. Whatever. Okay. So let's dive into variables, which is a super important concept in Python. I guess in Finnish, the word for variable is mutuja, but that is outside the scope of this class. And so you can use variables to store calculated values and use those values in other calculations, which is super nice because sometimes you don't know the value of something ahead of time. It's more of an intermediate step. And so you can store those intermediate values or final values in a variable and then use them later, whether that's to do more math or just to create a graph or something or create a report. So let's get some experience with assigning values to variables. So we're going to define a variable called temp Celsius, and we're going to set it to a value of 10.0. And then we're also going to print it out. So let's now do print temp. Oops. And you can see there's tab completion as well in Jupyter Notebook. So that's a nice kind of shortcut. You don't have to use it, but if you're lazy like me, you can. So now we print the temperature Celsius and we get 10. So that's pretty cool. We're slowly but surely building more complicated real world kind of examples of how Python might be useful. So storing the observation of maybe the temperature at a study site. So we can combine text and math to print out like we did above. So let's create a little kind of logic to convert or to just print out the temperature in Celsius as Fahrenheit. So to convert the Fahrenheit or the Celsius to Fahrenheit, we have to do some math. So let's start out by just doing the math and then we'll do the print statement afterwards. So temp Celsius still equals 10. Okay, cool. So we have to multiply that times 9 divided by 5. And then we have to add 32. Cool, 50. So it's the expected result. Oops, I pressed tab when I shouldn't have. Sometimes it happens. Okay, so now we have this conversion between Celsius to Fahrenheit. So now let's do, oh, I have caps lock on. Okay, print. Now we're just printing out that value. And finally, we can add a little bit of English. So temperature in Fahrenheit. It's a weird word. 50. Cool. Hopefully that's working for you all.
Hey,
Let me
hey,
know.
Alex,
What's up?
what are you using for the multiplication? Are you using the asterisk symbol?
Yes.
Okay. For some reason, it's not working for me. I'm getting an error. Although maybe
When-
it says syntax error unmatched. Maybe I'm screwing someone else up. I did temp underscore Celsius asterisk and then parentheses 9 divided by 5. Close parentheses plus 32, close parentheses.
So let's try it in real time. So do temp Celsius times 9 divided by 5 plus 32. Yours looks like that. And
Let me
it's good.
see. No, I got it now. I think
Okay.
the last parentheses after the 32 was not necessary. I put that there.
And this is the second common thing you'll run into with Python is matching or mismatched parentheses. It happens. It's just part of it. You start to catch them more and more as you get more practice. But yeah, this is a super common thing that you'll run into. So I'm glad that we're doing it live. Cool. But yeah, thanks for unmuting. I didn't see who was speaking, but thanks. Okay, so we're making our way through this lesson. Let's now check our understanding and define a variable and print its value to the screen. We've done this before, but let's do it again because practice makes perfect. And so the value can be anything you like. So surprise me and hopefully make me laugh when I check your labs, but definitely be respectful and follow the code of conduct. But let's have a little fun. So consider using pothole case naming for your variable. So Aka's dinner consisted of equals vegan pho from Jelly Donut in 29 Palms, California. Let us now print this. So it is forever now. Print my dinner consisted of Aka's dinner consisted of. Amazing. So maybe let me know what you had for dinner or some other silly thing about your day. But yeah. You can also update variables, which is super cool. I'm just going to keep proceeding, so make sure you either unmute or write in chat if you have a question or a blocker, but I'm just going to keep going. So we got a lot to cover tonight. So you can update those variables that are stored in variables. They're not unchangeable. You can totally change them. So we have temp Celsius, and it's currently equal to 10. Let's overwrite that. And let's set it equal to 15. And now let's print out temp Celsius and see what happens. And you can see it's been updated. So just know that you can overwrite your valuable or your variables, your valuable variables. So that's just something that you should be aware of. So other languages are stricter about that, and there's ways to kind of enforce that with Python, but yeah, you can overwrite variables. So if you have a variable that doesn't exist, but you try to invoke it, you'll get an error. So let's try to invoke this temp Fahrenheit variable that we don't actually have defined, and you'll see that we have a name error. And so you might encounter this as you're developing Python code. Just make sure that that variable exists. So if we define that variable below and then rerun it, that same print statement, we will not get an error. So let's try that. So let's set temp Fahrenheit equals 9.5 times temp Celsius plus 32. And then let's print out their values here. So I'm going to do a slightly longer sentence. I'm going to do temp. I'm lazy, so I'll do temp f equals temp Fahrenheit. And then we'll do temp C equals temp Celsius. Let's see if that works or if I have a typo somewhere. And I have a typo somewhere. So I don't think I actually ran this, or actually I did. But there might be a misspelling. So let's try that. Yes, there was a misspelling. Okay. Temp F 174.5, temp C 15. Seems wrong. Oh yeah, it is wrong. I did 9.5. I'm like, that seems like an incorrect conversion. Okay, let's try that again. Yes, temp F is 59, temp C is 15. That seems much more reasonable. Okay. So if you have one variable that's kind of dependent on another, you can kind of unlink that dependency by overwriting a variable value. So if we now change temp Celsius, temp Fahrenheit will not magically update, at least the way we currently have our code. And so let's change the value of temp Celsius to 20. And then let's print, let's print out temp Celsius and then temp Fahrenheit. So you can see temp Celsius is 20, and then temp Fahrenheit is still 59, even though temp Celsius has changed. So that's just a behavior that you should be aware of. So I think we're getting closer to the end of this lesson. Yeah, nice. Okay, cool. So the last part of this lesson is data types. And a data type kind of determines the characteristics of data in a program. Some of the most common data types that you'll see are integer, float, string, and Boolean. I believe these data types also exist in other software you've used, like ArcGIS stuff. And so this shouldn't be super unfamiliar, but if you've never seen it before, don't worry, because we'll get some practice right now and build some intuition. So let's define a variable called weather forecast and set it to equal hot. And then we're going to check the type. So weather forecast equals hot. I'm using my muscle memory is so aggressively tuned to doing shift enter that I'm just hitting it. So yeah, apologies if I preemptively run a code cell. I'm just, the muscle memory of pinky ring finger shift enter is just too much. So let's now do type, weather forecast. And so you can see it's a type string. Now let's check the type of temp Fahrenheit. Cool. And then let's try to see what happens when we do math across types. So what happens if we do temp Fahrenheit plus 5.0 times weather forecast? You can see we get this error. You cannot multiply a sequence by a non-integer type float. And so you can't really multiply the word hot by 5. And yeah, it just doesn't really make sense. And so Python kind of errors out. It just doesn't know what to do. So now let's check our understanding with some strings. So let's define two variables and assign them character string values. Let's do favorite I got food on my mind today. Favorite food equals, I always misspell burritos. Yeah, that's wrong. Burritos. Favorite color, black. Okay, and then let's see what happens when we try to do some math. Can we do favorite food plus favorite color? Burritos black. What about subtraction? So that does not work. What about multiplication? And then what about division? Nice. And so the only thing that actually works is addition. And so the behavior with addition is it kind of just smushes the words together. So this is something that you can use in your programs if you ever just have kind of variables that the values you need to just mush together. You can kind of just use addition and mush things, which is nice and a very technical term. So let's try, actually, let's skip this last section because it's optional and I'd rather do other lessons with you all tonight. And so let's save this, saving completed. You can also do file save. And now let's do an example of downloading and then uploading to GitHub. So I'm going to download this file. Hopefully you see how it shows the save menu on my screen, but I'm going to save this to my downloads. And you can see I have an IPYNB file now. And if I return to my GitHub repository and I select add file, upload file, I can choose a file, specifically the one that I just downloaded. And we can commit our changes. Don't worry about doing any kind of message. And this might take a second, but the GitHub user interface will now update and you'll see the file that I just completed. And we're now a quarter done with this week's lab. And you can see Burritos black, you can see all the stuff, the outputs. So this is super nice. I will be able to check that you worked through and tried these examples. So this is kind of the workflow for the remainder of the labs. I don't know if we'll get through all 4 today, if I'm like kind of talking and narrating through it, but we'll try. And so at this point, we can close Binder, at least that previous tab, if you've downloaded it to your computer. And we can proceed with the next lesson. Are there any questions about the A Taste of Python kind of sub-lesson that we just went through?
Yes. When we upload to the GitHub, are we able to edit the code in there? Or once you upload it, okay, since you're uploading it as a notebook, then would you be able to edit it in GitHub?
So you can, if you then kind of open it in a code space, you know what I mean? Or like some kind of, so like behind the scenes, this notebook just looks like this. I think you can still see my screen, but it's kind of just like an ugly data structure. GitHub magically kind of renders this. If you want, you can edit the file, but I don't think that it's going to look nice when you're editing it. You see how it doesn't actually
yeah.
show. So
Yeah,
if you want to change it, you have to do it using like a program like VS Code, or let's see if we can do it here. So I'm going to open with github.dev. Let's see what happens. So now this is a web editor. and it's actually showing me a way to, actually this might work, or no, it could have you open. Oh, open and text it.
Okay.
Oh, wait, are we getting there? No, okay, so yeah, it doesn't like that for some reason, but you can use this file. Like if
Okay.
you can download this file and edit it, you just need the right editing software. It's all free. You
Maybe
can
like
go ahead.
or like in pause it in like Porto or like even in Arc Pro notebooks maybe. It's an IPYBM.
Yeah, no, you
Oh.
could upload this to ArcGIS notebooks. You could open this in Google Drive and edit it there. There's like a way to edit Python code in Google Drive, which is super cool, called Google Collaboratory. I'll share a link to that now, but this is like another environment that you can use to practice coding in Python, and they give you some example Python code, and it's attached to your Google account, and you can just kind of upload and do stuff there. You can also link that with your GitHub. Sometimes there's issues with authenticating across these services, and so that's why I'm doing more manual upload and download. But if you link things like that, then you're able to more easily edit and modify the file without having to manually upload. So hopefully that explains it a bit.
Thank you.
Yeah, you're welcome. Good question. Oops. Okay, let's keep going. Now we're gonna do Python basic elements. And as with before, let's launch it in Binder. Might take a second to initialize, so I'm just gonna let the spinny wheel spin and take a sip of my drink. Okay, cool. So we're back in Binder. We're going to do the same thing, running through the cells. Once we're finished, we're going to download it and then upload it to GitHub. As before, this is heavily inspired by the software carpentries, but with a slightly finished spin as delivered by a Southern California. So it should be interesting. So in the previous lesson, we encountered things like variables, some math, and now we're gonna dive a little deeper with using certain basic building blocks of Python. And so one thing that you're gonna see a lot of is lists. So they're also called arrays, but it's the square brackets, and it's when you see these square brackets and they're comma separated items inside. And so you'll encounter lists time and time again in your Python work. And so let's create a list and do some tinkering with it. And so this list has station names from Finland, or the Finnish Meteorological Institute, and their observation stations in the Helsinki area. So let's save this variable. Thankfully, they pre-populated those because I don't speak Finnish. So if we do station names, now you can see we have this, it's kind of like it's still a variable, but instead of just containing one value, we have a bunch of values, which is pretty nice because oftentimes you want to run the same operation on a bunch of different data. And so a list is one way that you could maybe have maybe a list of 10 CSV files that you need to do something on, or 10 shape files. You get the idea. So let's check the type of this list and see how Python is viewing this behind the scenes. Oh, not too insightful. It's a list. Okay, cool. So I hear
question.
unmuted. Yeah, go for it.
Yeah, I just typed in station names and just like that, it already says name error, and it says that station names or station underscore names is not defined.
Yeah.
I don't know.
Did you run this? Did you run this?
Oh,
Yeah.
there it is. Thank you.
Yeah. No worries. Yeah. This is great that we're doing it in real time because yeah, this is the pain of Python. It's like, what is going on? But oftentimes it's really just you forgot to run something or there's an extra parentheses. So I'm glad that we fixed that. Cool. So we have this list with 4 items, but sometimes you want to like access a specific item. So you can do that using indices. And so we're going to select the index of the list or we're going to index the list for a specific item. And so we can do that using kind of more square brackets. So we're taking station names and then we're taking the 1th item. And so you might expect that to be Helsinki Harmaja, but it's actually Helsinki Kaisaniemi. And that's because the first number in Python or counting in Python doesn't start at 1, it starts at 0. And so the first item in a list in Python is actually the 0th item. And so to get the first item, you would do Helsinki or you do 0. If you want to get the last item, you can do -1. And so you can see Helsinki Kumpula. And so just to reinforce that, you could also do number 2, and that gives us that one. I'm not going to try to pronounce that. So here's an analogy. Build a vending machine. Hopefully this doesn't confuse you more than not having seen this, but there are 6 items in this vending machine. And Bill lists these items starting from 0. You put money and you select the item, like a vending machine. I don't know why this is here, but maybe, hopefully this helps you. I don't know if this really helped me internalizing list indices, but I guess it's kind of just referencing the position of data somewhere. So the hamburgers are the 0th item in the vending machine by location. And so you could get hamburgers by smashing the 0 button, kind of how we put in the 0 index or the 3 index. So hopefully that makes sense. Sometimes you don't know how big a list is because people can add more things to a list. They're not necessarily unchanging. So it's useful to get the length. Sometimes you want to maybe do an operation on everything in a list. So you can see that this is length of 4. There's 4 values in the list. So I kind of did some teasing of this already out of order, but you can also index things based on the relative position to 0. So you can do index position of -4 or at -1. So that's like station names -1. You can also run into errors if you try to index or try to pick the item at a position that doesn't exist. And so if we put in station names 4, you'll see that the list index is out of range because 4 doesn't actually exist. We stop at 3 because we begin counting at 0. If we try that with a negative, you'll see that that works. So there might be some slight confusions when you're doing list indexing, but I think the most common errors you'll run into are list index out of range because you're trying to point to something that is outside of the actual list size. So yeah, I'd say this is the one to watch out for most, the index error. If we try to check a list outside of the range, even in reverse, let's see what happens. Yeah, so -4 works, but -5 is outside of the reverse ordering range. And so it's kind of a weird way to count. It's like counting backwards from 0, but it's there. And sometimes you'll want to do that. There's a polling option, but we're not going to do that because this was more for just the real-time finish students. So now that we have kind of tinkered a bit with lists, let's dive deeper. So I mentioned that lists can change, and so let's get some exposure to that. Let's add another, or let's update the value of this list. So station types is this new list that we're creating, and I just said list about 30 times. Apologies. You can see that it just says weather stations 4 times. Let's now update a value in place. So we're going to do station types 2 equals Mariographs. And then let's print out station types. Also, I'm like super curious what a Mariograph is now. Tide gauge. Okay. The more you know. So you can see we've successfully updated our list and just at one position, the 2 index. So if you're counting at 0, that's actually the 3rd item in the list. A nice thing about lists is that you can store different kinds of data. Sometimes that's good, sometimes that's bad. If you don't know in advance the kind of data that you're going to get, it's great. If you're trying to build a really reliable and robust system that expects certain data, it's not great. So let's create a list with a variety of different data types. So the first variable will be a string called the Helsinki Kaivopuisto. Then we have a station ID, which is an integer. We have a station latitude and a longitude, which are both floating points. And then we have a station type, which is also a string. So now let's create a list which kind of has all the metadata about this Helsinki Kaivopuisto station. And then we'll print it out. So you can see we have a list with strings, integers, and floating points. 3 different data types. And then if we do type of station El Kaivo, we have a list. If we do the type of that list at position 0, and I hear someone unmuted, so what's up?
Filled.
Hello?
Hi, can you hear me?
Now I can. Yeah, it was just cutting out.
Oh, okay. How do you do the thing where you autofill the name?
So if you start doing station H, and then if you press tab, it just does that. It's just like tab completion, like on terminal. And if there's more than one variable with that name, it'll give you an option, or it'll give you like a list. So yeah, it's just tab completion. Hopefully that helps. Okay, so you've added values to, or we've updated values in a list, but now let's actually add new data to an existing list. So let's remove something from station names. So first, let's print out station names to remind ourselves of all the Finnish words that we don't know how to pronounce. Cool. So let's delete the 0th entry in the list and then print out that list. So we're using the del function. And let's print out station names. And you can see now we have 3 stations. So we effectively deleted one of our data points. There's many ways to remove data from a list. The del method is just one of them. You can also use a remove method or a pop method, but those are just 2 or 3 different ways to do the same thing. So I encourage you to try that out in your free time, but I'm going to skip that for now. So we have our list station names, and we can modify that using built-in methods, but let's see what happens when we try to use this append method. So let's create a variable called station name length. And we want to set that to the equal to the length of the station names list. And then let's print out that variable. So it's 3. Cool. We also want to check the variable type of station name. So let's see what that is, or station name length. So type station name length. So let's try to append station name typing. Append 1. Ooh. So we get an attribute error because there's no built-in method to the integer type to append integer data. So let's try to make sense of what's going on here. So this station name length, it's an integer. You can't really append a value onto an integer. You can do math like plus or minus, but the append method is mainly for non-numerical information. It's not thinking about arithmetic so much as just smushing things. And so that's where if you want to maybe add 1 to something, you would do plus instead of append. So some other useful list methods, counting. So let's count the number of times a value occurs in our list. Station names dot count Helsinki Kumpula. Once. How many times does Helsinki occur? 0. Okay, because that's interesting. So it must match the entire phrase, not just a single word. There's other ways to just do partial matches, but this count method is not one of them. So let's find the index of Helsinki Kumpula, because we know it exists once, but we don't actually know where it exists. So let's do station names dot index of Helsinki Kumpula. And it occurs at position 2. Very cool. So I believe we have a couple more methods that we're going to cover, all related to lists, but kind of bear with me. We're getting there. So the next method we're going to do is reversing a list, and oftentimes this is helpful. You'd be surprised. So we have this station names list, and then if we reverse it, we should get the reverse order. Nothing happened because it's actually reversing it in place. So let's create a new cell and see that it actually reversed it, and it did. So that's good to know. It doesn't just, yeah, so this is a common mistake when reversing lists. You don't need to set it to a new value, or you don't need to like take the variable name and then reset it to the reversed version of itself. It just reverses in place. If you try to set it to a reversed version of itself, it'll just be empty. And so this is kind of like a quirky gotcha of Python. So just to give you an example of that, I'll make a playlist, example list equals Alice, Bob, Charlie. So if we do now example list equals example list reverse and print example list, it's empty because the type of the reversed list, it's nothing. It's just kind of, it's moving it in place. So just trying to explain this caution section with the real example. So similar to reversing a list, you might want to sort a list. So let's try that. Station names, sort. And now you can see that it is in alphabetical order. Cool. But like with reverse method, nothing is output to the terminal or console. When you run the sort method, it just kind of silently sorts the data in place. So you can make data work together. Not all data works with all data, but let's explore a little bit about the different data types. And we'll get started with checking the data types of station name, station ID, and station lat. So station name is a type string. This should be a type integer. And then this should be a type float. And that's a typo. Cool. We try to add variables of different types. Sometimes it works, sometimes it doesn't. Station name plus station ID. Get an error. Station lat. There we don't get an error, even though it doesn't really make sense, but the types are close enough that Python can kind of figure out what to do. You can add an integer and a float a bit more easily than adding a word and an integer. And then another thing that is commonly done in just computing, but also GIS, is converting between data types. And so often you'll convert between a shapefile and a GeoJSON or something else. And so here you can convert between an integer and a float. So let's practice that. Let's get the string representation of station ID. And we can save that as, oops, a variable called station ID str. And let's get the type of that. Type of a station ID str. It's a type string. Very cool. And you can see that instead of being, oops, in being a number, now there's actually quotes around the number so that it indicates that it is a string. You can also convert strings into integers. And you can do that using like integer station ID str. And now it's back to being an integer. So you can kind of interconvert between data types depending on the data types. And I think to close out this lesson, we're going to start discussing kind of combining text and numbers. So that's another thing that you'll run into. So let's create a text string with the variable station name and ID. And it's a combination of two other variables. So station name and ID equals station name plus station ID. Print station name and ID. Ooh, we got an error. So let's use the station ID str, which is the string representation. So we got Helsinki Kaivo Puisto 132310. So you can see how we're starting to convert different data types together. So previously we did a little bit of printing where we're combining variables and sentences. There's many ways to kind of inject variable information into text, like dynamically formatting strings. F strings is one of those. So let's get some experience with that. Some more legacy versions of doing this are the format method and the kind of percentage modulo operator, but the F string method is the most kind of industry standard, newer way of doing things. So let's do that. We have a variable called temperature, which we've set to 18.5, blah, 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 with many, many decimals. Let's now use the F string method to print out the number with a rounded data. So let's do print F. Inside this F string, we'll do the temperature. Actually, we're going to totally just copy pasta this text here. So let's do info text equals F, the temperature at station name, station ID, is temp 2F. And so that's two, what's the word? Decimal points Celsius. And then let's print out info text. Temperature at Helsinki Kaivo Puisto station, ID 132310, is 18.57 Celsius. So you can see how we're very quickly creating a complicated kind of sentence with dynamic information that we don't necessarily know ahead of time. But this is really cool. We could create a report. Maybe you have a global view on all your data sites and you want to know the temperature at all times. You could write a tracker or something. And this figure gives you some examples, or it gives you more insight into how Python formats numbers and decimal points. But I'd say the main takeaway is the fstring method. It's like a string, but there's a preceding f, and then you're able to kind of use curly brackets to inject variable names into your string, and then Python magically handles that and creates a beautiful string for you. These are less recommended formatting methods, which thankfully we don't have to worry about, but it's slightly more verbose in a different way and not as intuitive. And so I'd encourage you to just run this code cell, but you don't have to really tweak it or tinker with it because it's already done. Similarly, this code cell here uses a legacy version of string formatting that is not recommended really. So with that, we finished the second lesson of tonight. So I'm gonna download that and then upload it to GitHub. What was it called? Python Basic. Okay. Stop sharing for a moment. Okay, we still have 15 people here. Great. So I'm going to close this because we're done with it. And then let's take a look at the next lesson. Cool. So this will probably be the last one for tonight. And then I will leave conditional statements for you all to work through by yourselves. But let's get into it. I'm going to, as usual, open this with Binder, wait for it to load, and take a sip of my beverage. Almost ready to go. Right. For loops. So we were just doing a lot of list stuff, but one thing that is kind of hand in hand with lists in Python is looping. And so you can kind of iterate through everything inside a list and do something on it. So literally, like for each item in a list, do this. And so we're gonna get some exposure in this lesson on what that looks like practically with Python. So we'll start out with this list of European city names and read that into memory so we don't get any name errors. And now let's get going. We could use the index of each value in our list. So like European cities, 0 or 1, and do that manually. Like if we want to print it out, we could copy paste, print European cities 1, print European cities 0. But you can see how that's annoying after more than like 2. Let's now try that with new lists. So what happens if you do like 3 here with European cities, but now if you have a different data set and you try to do print European cities 3, you run into our trusty old friend, the index error. And so there's got to be a better way. For specifically those cases where you don't necessarily know how long the list is. And so that's where we're going to do a for loop. So let us do that. So we can see that it's a length of 4. So that's not too bad, but imagine this longer list with US cities. It'd be annoying to print out each one of these individually. So we can use a for loop to automate that. And so for a variable in a collection, we want to do things with that variable. So in this case, we could, for city in US cities, print city. So let's try that real quick. I'm going to do for city in US cities. And then you want to have a colon to indicate this is a for loop. And Python will automatically indent your text because it's a for loop. So let's do print city. Nice. And so this is kind of your first example of automating things. You're looping through a bunch of variables and doing something to them. So I'm going to skip over this daily for loop thing cartoon, but I encourage you to check it out. But you can see you can think about a for loop of your day, like, oh, for every day in the week, you wake up, you take a shower, you eat breakfast, you brush your teeth, and you do a bunch of other stuff. And if your life was a program, you could just have this running on repeat in perpetuity so that you remember what to do if you were a robot. So let's get some more practice with this for loop and try it with a different list example, this time with some weather conditions. So let's try another for loop for weather in weather conditions. Print weather. And so you might be wondering, is there some kind of magical secret sauce that I know about how to pick the variable name here? Not really. It's really just something that makes sense to you. It's kind of arbitrary what you pick. You could do for Pekka in weather conditions, print Pekka, and it would work. It just doesn't really make sense for like someone else who's reading your code. So it's kind of just best practice to pick a variable name that makes sense. So if it's a list of weather conditions, I guess you could do for condition in weather conditions, print condition. And that also works. So it's really up to you. Just stick with variable names that kind of make sense to you and your collaborators. So we've just been iterating over lists, but you could also write a loop that performs a calculation a specific number of times. So say you just want your computer to count or to like wait a second 5 times. It's not tied to the length of a list, but you just want to have it a specific number of times. To do that, you can use the range. And so let's try to do that. For value in range 5, print value. So in this context, the variable is just getting the number, which is pretty nice. So this is kind of just an auto incrementing list of values. So this is shorthand for creating a list where the values are incrementing. You can just use range to magically create a list of kind of auto incrementing IDs, which is pretty nice, especially when you're building like applications and stuff. And as before, the list indices start at 0 and end with the length -1. So we just did the for value in range 5. We can also do for I or for other variable in range. There's like a variety of things you can kind of specify the bottom and the top and the skip for the step size. So to learn more about a function, you can do help range. So you can start, the stop, and the step. So let's try to, so range 5 is just, actually here, let me do a little copy paste. So this is the example we're already familiar with. It's using just range 5. Let's say we want to do from 5 to 10. So now we're doing 5, 6, 7, 8, 9. It includes the bottom, but it does not include the top value. And then if we want, we could also introduce a step size. And so now we're skipping. And so here we're going from 5 to 10, but skipping. So it's going from 5 to 7 to 9. You could also do a step size of 3. You can see how that affects your range of values. So let's do some more digging with looping and ranges. So we have a list of African cities, and let's print out their names using a for loop. But we also want to use the range function to print the cities. So let's try that. For city and African cities. Print the try this. Or city in actually, yeah, I'll do this one first. This is the expected case. Now what happens if we do for city in range African cities? Get an error because you, okay, cool, good to know. And finally, range African cities. Just trying to understand what that, okay, perfect, good to know. So this last sentence of, however, this time we will also use the range function to print cities. I'm not exactly sure what they mean by that, but let's keep scrolling down and see if we maybe understand. Oh, now I know, okay. It's been a minute since I did this because I usually just, I don't bother with this method. Okay, so for I in range len African cities print I. Okay, that's, I'm missing a closing parentheses. There we go. 0, 1, 2, 3, 4, 5. So we could also do for I in range len African cities, print African city I. And so you can see this is a different way to kind of do a for loop on a list. You're actually pointing to the specific index of the entries instead of kind of looping through using the for blank in list. So hopefully that makes sense. Why use index values to loop over a list? You might be asking yourself. There's two common cases where you might need to do this. If you want to update individual values in a list, you're going to want the index values. And then you're going to want to do this when there's multiple lists that are related to one another. It's helpful to use these indices. And so now we'll have such an example. So let's create a list of cities and countries. We have 5 cities and countries. And let's try to print this out in a single for loop. So let's see what they say as tips. The index I is used in the case to access each item in the 2 listed cities, and let's print out city country pairs. So for I in range len cities, print cities I, countries I. And because cities and countries lists are the same length, you can kind of move through them together. So let's try this out. So you can see we got the city country pairs with a single list. For I in range len cities, print cities I, countries I. You could also replace this with countries, and you should get the same exact result, because they're both the same length, and I is the same for both of them as you kind of loop through it. So let's try a little mental exercise, and then we can run this and see what happens. So we have a list of odd numbers and a list of even numbers. So if we loop through the range of odd numbers, what do we expect the output to be? So so for I in range len odd numbers, so the first one would be here, odd numbers I plus even numbers I would be 11. So 11. The second one would be 3 plus 4, 7. Then we'd have 5 plus 6, 11. And then 7 plus 8 is 15. And then 9 plus 2 is 11. Cool. Now let's try and actually code that out and see what we get, and see if Professor Paca can do math tonight, or if he's too tired. Even numbers equals 10, 4, 6, 8, 2. And sometimes you might see me skipping the spaces. You don't have to put spaces. It's usually better practice because it makes it more legible. But if you're just trying to quickly type, you can skip the spaces. But really up to you. For I in range len odd numbers, print odd numbers I plus even numbers I. Invalid syntax. Okay, I missed an in. For I in range. Ooh, error. Okay, that's because this should be odd numbers. And so you might run into that where you think like, why is this not defined? You probably just one is plural and one is singular. This will happen so many times. It still happens to me. It just is what it is. And so was I able to do math? I was. Awesome. Okay. So this is the for loops lesson. And actually it went way faster than I was expecting. So we can definitely go through the last one too. So let me save this, download it, and then we'll move on to the final lesson of the night. And then we can all get going. And I see Andrea has raised their hand, so feel free to unmute.
The I is kind of like the Paca, like it's just an arbitrary variable that you chose, correct?
Yeah,
Okay,
it could
just wanna
be
confirm.
J. Yeah, it could be like it could be like you could do for for Turkey in, and then yeah, it could be arbitrary. It's literally whatever
Okay.
you want. Yeah,
Awesome.
it's just
Thank you.
you'll see I very often though, just because
Oh.
it's short and to the point.
Thank you.
Hey, you're welcome. Okay, it's processing our files. I'm going to close Binder. So now you can see we have 3 IPython notebooks, 3/4 of the way there to 100% score on this week's lab. I noticed that there is a typo on the lab instructions, so my bad. It says navigate to lab 6. I will update that. It should be lab 5. So if that's confusing, let me actually fix that right now before I forget. And then we'll continue with the final lesson of the day. You're seeing how the sausage is made. Gitbook is a really cool product. If you ever need to create like knowledge bases or course material for a class or even for a business, it's super convenient. And it ties in with GitHub, which is really nice. And there we go. The instructions should be updated to reflect the correct lab assignment. Now let's get into the final sub-lesson of the evening, conditional statements. This one also a short one, which is good. So let's open it with Binder. Another nice thing about Jupyter, you have options to change the theme. You can also do custom themes, but there is some customizability. The kernels this is where you can have like different environments besides Python. You can see here there's the Python 3 PyKernel, but there's ways to have different programming languages connected, which is really nice. But that's an aside. Let's jump into conditional statements. So conditional statements are when you want to kind of have code that behaves differently when certain conditions are met. So say maybe it's raining outside, do this thing. Otherwise, do something else. Maybe if there's minimal cloud coverage, download the Landsat data. Otherwise, skip it. It's not worth it. So today, let's mess around some more with temperature because it seems like this class is, I mean, that makes sense as kind of metrics that we care about as geospatially inclined folks, temperature, maybe elevation. So let's now set a variable equal to a temperature of 17. And then if it is greater than 25, we're going to print hot. And if it is below 25, we're going to print not hot. So if temperature greater than 25, print hot. Else, if temperature below otherwise else, not elif, else, print not hot. So you can see our temperature is not hot because it was below 25. So we're using an if and else statement to kind of check our condition and then do work depending on whether the condition is met. And you can see it's a similar syntax to the for loop, where you have kind of a statement that ends in a colon, and then the subsequent line is indented. And so that's a common pattern you'll see in Python, is doing this sort of kind of structure in your code. And it makes it pretty easy to then read and quickly scan through a script and understand what's going on. So now let's update our temperature to a hot temperature and then rerun our logic. So I'm going to copy paste that logic. But first, I'm going to do temperature equals, let's say 33. That's a little spicy. At least if we're in Celsius. It's not super spicy, that's a little spicy. So you can see now temperature is hot. Very cool. So if we don't use an else in this if, let's see what happens. So, because else is not strictly required. So let's just see if temperature is greater than 25, print hot. Or if temperature is greater than 29, print hot. But for other cases, we're just not doing anything. We're kind of just skipping it. So if the temperature is below 29, just don't do anything. So what about if the temperature is above 35? In this example, because our temperature is set to 33, nothing happened because it's below the threshold. So there's not actually a condition that's satisfied that has work. So it kind of just continues silently. Now let's try with another kind of example from our daily lives with the weather, using if and else. So imagine you're getting ready to leave your house and you want to decide what to wear. So you might check the weather conditions, whether that's on your app or you're just going outside and looking at the weather. You're kind of checking some data. So let's use if and else to kind of codify that logic. So we're going to set our weather equal to rain. And so if weather equals rain, print wear a raincoat. Else, print no raincoat needed. And so you can see here, because the weather is rainy, we need a raincoat. How about if we set weather is dry, hot, and sunny? See, no raincoat needed. And to kind of check this equality in the condition, we're using a double equal sign operator to test if a value is exactly equal to another value. So let's test our practice or test our understanding a little more. And I previously mentioned the colons, but you'll see a lot of colons in Python, and you might run into indentation errors or syntax errors if you maybe have a colon in the wrong place or you're missing a closing parentheses. So just keep an eye out for that. So let's add another instruction after the if weather equals rain, where you should also wear boots if it's raining. So print wear rain boots. No raincoat needed because the temperature is, or the weather is hot and sunny. Let's do weather rainy or weather rain. And you can see wear a raincoat, wear rain boots. We foreshadowed some of these comparison operators previously with the greater than or equal than, but you can kind of do greater than or equal to, similarly less than or equal to, or a not equal to. And so you'll encounter these throughout your Python journeys. So let's now explore some Boolean values. So let's check that the current value of the conditions we used in the previous examples. So if whether let's see how we want to do that actually. Comparison operators yield Boolean values. So if type whether is string, or no, how do we want to do this actually? Let me think about that. Let's check the current value of the conditions we used in the previous example. So whether equals rain, true. Okay. Whether not equals rain, false. And then can you do greater than? Whether less than rain, false. Yeah, so that doesn't really make sense, but yeah, you can run those comparisons as well. Something that I hinted at previously, but we weren't actually covering it, was the elif, but you can have multiple if clauses. So if condition A is met, do something. If condition B is met, do something else. If condition C is met, do something else, and you can keep going and going. And you specify that using if, elif, and else. And so let's get some practice with that. So let's set the temperature -3, read that into memory. If temperature greater than 0, print is freezing. Oh no, print is above freezing. Sorry, I skipped the line. Else if temperature equals 0 exactly, print is freezing. But else print is below freezing. So because our temperature is set to -3, we get the result of is below freezing. But you can see now we have multiple kind of conditions. If we set this equal to 0 and run it again, we get is freezing. If we add in another option, elif temperature equals cat, print meow. And so we need to run that, and then we get an error. And so you can't compare a string and an integer. And so this is where you might run into issues too with type errors. So I just wanted to show that to you all in case this is something you run into during your explorations. So let's check our understanding again and look at some kind of more complicated elif examples. So let's do this mental exercise, and then we'll actually write the code out and see what the answer is. So if yesterday was 14 degrees Celsius and today is 10 and tomorrow will be 13, we're going to write some code to compare these temperatures and print something to the screen based on this comparison. So if yesterday was less than today, print A. Else, if today is not equal to tomorrow, print B. Else, if yesterday was greater than tomorrow, print C. Else, if today is equal to today, print D. So if today is equal to today, I think that we're going to get a 10. Yesterday was less than or equal to today. It's false, so we're not going to get an A. Today is not equal to tomorrow, so we're not going to get a B. Was yesterday greater than tomorrow? Yes. So I think we're gonna get a C and a D. But let's type this out real fast and see if I'm right or if I'm way wrong. A, print A. Lift today, not equal to tomorrow. Print B. Elif yesterday is greater than tomorrow. Print C. Elif today equals today. Print D. And from what I recall, I expect that it's going to print out a C and a D, but let's see what actually happens. If I'm right, if I'm wrong. You got a B. Okay. So it only picks one. And so that it doesn't kind of leap through all possible iterations. It finds the first one and then kind of exits. And so is today not equal to tomorrow? It's not. So we get a B. And I guess I misread that when I was listening through the options. So yeah, that makes sense. B. Now, as we kind of finish out the evening, let's do some more complicated conditions. And so sometimes you want to check if condition A and condition B are occurring, or maybe condition A or condition B. And so Python lets you do that using the and the or operators. So let's try that here. So let's create an if statement that uses the and keyword with two conditions. If true, print both parts are true. If false, print at least one part is true. So let's see what happens if true. Print both parts are true. If false, print at least one part is not true. See what happens. Both parts are true. Okay. Doesn't really make sense because we don't have let's just do data exists equals true. If data exists equals true. If data exists equals false. Both parts are true. See what happens now. Okay. So that doesn't make sense. And so if data exists, oh, okay, I misunderstood that. My bad. Okay. If data exists equals false, and then how about color equals purple? If data equals exists equals true, and color equals purple, print both parts are true. Else, print at least one part is not true. So my bad for misunderstanding that, but we're using this and operator to specify two conditions. So we have a variable that we set to false and a color purple. So let's see what happens. At least one part is not true. Now let's rename that to true, and both parts are true. And so we're checking two conditions now, and our program is easily doing that, which is kind of nice. You can similarly do or, and so let's try that. If data exists or color equals purple, print at least one. Actually, change it to elif. And we can copy paste this and replace the and with an or. And then we're feeling real fancy, print. I could use a snack. So both parts are true. Very cool. Let me copy this out so that we can actually have a better experience of Tinker. So if now one is true and one is false, what do we get? At least one part is true. Then what happens if neither is true? I could use a snack right now. Nice. Later in the course, we're going to do some other operators that let you do some more fine-grained comparisons, but for the sake of day one with Python, and an or is more than plenty. So now let's check our understanding again. Imagine that on this rainy day where we're trying to figure out what to wear, we're not only considering the precipitation, but also the wind speed. And so if it's windy or raining, we just want to stay home. If it's not windy or raining, we can go out and enjoy the weather. And 8 meters per second is the limit for a fresh breeze in Finland. So we can set that as our comfort limit. And so let's imagine that the Finnish Meteorological Institute has forecast strong winds in Helsinki. Let's see what the Python code tells us to do. So if weather equals windy, actually no, if weather equals rain or wind speed greater than 8, print stay home. Else print, oops, go out and enjoy the weather. So it's rainy and there's high wind speeds, so don't go out. How about hot? Stay at home. How about wind speed of 5? Go out and enjoy the weather. But what if it's rainy and it's low wind? You should still stay home. Okay, and so you can see how we're creating slightly more complicated logic to check conditions and follow a different action based on those conditions. And then to finish up tonight, we are going to combine for loops and conditional statements for one last exercise. So let's iterate over this list of temperatures and check whether the temperature is hot or not. So for temp in temperatures, if temp is greater than 25, print is hot. And so you can see we printed that out twice, but it doesn't really tell us what's going on. So let's actually pass in the variable so we know what we're talking about. 28 is hot, 30 is hot. Nice. If you wanted to, you could also get the indexed position in the list so that you could specifically check that data point, but we don't have to do that right now. But this kind of gives you an idea of some of the things you can do with loops, conditional statements, and how you can start constructing pretty complicated logic for your programs. And so with that, we finish the final lab of the day. So I'm gonna save this, download it, upload it to GitHub. And that's really about it for tonight. I will open the floor to you all if you have any questions, if you're running into any issues with your code, but you are free to head out and spend the rest of your evening however you see fit. The lab is due next week, and it just requires the URL to your GitHub repo. So if you want, you can even just submit that right now and then work on those labs throughout tonight and the remainder of the week, but it's really up to you. I am here, so just reach out. Yeah, thank you all. It's good to see you. Sorry about the audio issues earlier, but yeah, we're in the home stretch.
Hey, Alex.
Thank you.
Thank you. Yeah, what's up, Matthew?
I'm gonna send a photo. I took a screenshot in the chat. I'm gonna see if you can open it. This is in from the for loops. I just want to make sure I'm on the right page here. I'm not really sure what's really asking here. If I'm doing it correctly or I'm getting the gist.
So you mean the one that's okay, so like where it says 39?
Yeah. And
Yeah,
I guess
40.
I get 40, yeah.
Yeah. Okay, so the 41 might be easier to start. And so if you do for I in range len African cities, and then you do print African cities, and then you replace 0 with an I, what does that look like?
Ah, it's a list. Got it.
Yeah. So you just had the wrong thing, but yeah, it's totally there. And then
Yeah.
the reason why the 39 one looks weird is it's just printing the whole list each time.
Right.
Yeah. Yeah.
Sounds good. All right, great. Thanks.
Yeah, you're welcome. You have a question, Andrea, or are you just unmuted?
No, no, I didn't realize that everybody just dropped off because sometimes people stay. Okay, have a good night.
Yeah, you too. Yeah, no worries.
I'm gonna head out.
Okay, cool. Yeah,
Have
see
a
ya.
good night, Alex.
Yeah, see you next week. Thanks.